Hello, everyone. Welcome to our seminar. It's my pleasure to introduce our today's speaker, Seth Arens. And first of all, I wanted to thank him for agreeing to give a seminar today here to us. And let me give you a short introduction who Seth is. He has a degree, a BA in biology and environmental policy. And then he has an MS in biology from the University of Alaska, and another MS, it seems like, in biology from our university of Utah. And Seth worked in various positions, as he just explained to me. And one of them was he was interested or concerned about ozone pollution here in Utah. So he worked for the Utah Division of Air Quality. Not exactly sure for how long, but since 2015, he started to work for the Western Water Assessment. And I hope he's going to tell us a little bit more what this Western Water Assessment is and what it can do and he can do for Utah during his work, in terms of his work. Okay. So with this, I hand over to Seth and look forward to listen to your talk.
Thank you, Thomas. And thanks for the invitation to speak. I appreciate it. Just share my screen.
Yeah, that looks good.
Okay, great. Well, I am going to be giving you a talk about developing applied and usable climate research through stakeholder engagement. So Western Water Assessment is a University of Colorado-based research group that's funded through the NOAA RISA program. The RISA program is housed under the Climate Program Office, and it's the Regional Integrated Sciences and Assessment Program. This program's goal is to build relationships that local decision makers and researchers collaborating on climate change. RISA expands the nation's capacity to adapt and become resilient to extreme weather events and climate change. Western Water Assessment was established in 1999, which was just a year after the RISA program began in 1998. As I mentioned, we work while we're based in the University of Colorado in Boulder, we work in Colorado, Utah, and Wyoming, and we've had a physical presence, meaning someone actually living and working in Utah since 2010. Our organization's in the past has focused on working on water resources, drought, and Colorado issues and research. Our current focus on a new grant that we just started in September focuses on adaptation and resilience to compound natural hazards in the face of a changing climate. And throughout all the work we've done on different topics over the last 20-something years, climate science and providing climate projections and climate information to users of that climate information is a common thread and one that I think resonates with this department. So
go to the pool. I know. It's pool.
Western Water Assessment,
right down there. Oh my God.
Western Water Assessment, our mission overall is to conduct innovative research in partnership with decision makers, helping them make the best use of science to manage for climate impacts. This includes working directly with communities and water systems to build resilience to compound hazards, focusing on the needs of frontline communities. And what I mean by frontline communities are communities within our 3-state region that are underserved in some way. So maybe they're rural communities, poorer communities, communities that are more ethnically diverse, or for some other reason don't typically get access to some of the climate and science information that larger communities might have. A goal is also to advance user relevant research related to climate change, snowpack, wildfire, and water supply. And also integrating and making a priority social science research techniques throughout our work. One of the things we really, while I am not a social scientist, I have a physical and natural science background. Many others who work for our organization do focus on social science, and we think and work a lot on the process of working with stakeholders and how to work more effectively with them and to develop effective, applied, and usable research. So just to give you a little sense of how our program's organized, we have a relatively small staff. It's really just 5 of us that are our full-time staff. Everyone aside from myself is housed at the University of Colorado. On our grant, we have, in the past, the principal investigators on this grant have all been from the University of Colorado. But on our new 5-year grant, which just started this past September in 2021, also includes a principal investigator from the University of Utah, this department, Court Strong, and a principal investigator from the University of Wyoming. Kind of how we work, you can think of kind of concentric circles of collaborators. We have this core staff of 5 full-time employees, and then we work with the principal investigators, and then we also have investigators that aren't PIs on the grant, but that are written into projects on the grant. And here at the University of Utah, that includes Divya Chandrasekhar, Logan Mitchell, and Danya Ramore. And then we also have other researchers, especially at the University of Colorado, that we've collaborated with for many years that are kind of part of that team, even if they aren't officially on our grant. So this is the group of principal investigators, and I really just showed this slide to highlight Court as being one of our principal investigators. And for me, this is really a great move in this direction. We've worked in a 3-state region for 20 years, but we've never officially been connected by having a principal investigator at universities in Utah and Wyoming. And myself, I've been housed at the University of Utah, really not in an official capacity, but just by the good grace of various departments. Since about 2018, I've had some form of office space here at the U, either through the Global Change and Sustainability Center, Department of Geology, the law school, and now the Department of Atmospheric Sciences. So I'm really excited that Court and the University of Utah are an official part of this grant. And our core team here, as I mentioned, there's really just 5 of us. Our director is just part-time as the director. He has plenty of other duties as a professor and researcher in the Department of Hydrology at the University of Colorado. So for much of the talk, I'm kind of going to structure this on talking about the different functions that Western Water Assessment has. While we are a research group, not all of the work that we do is purely research. Certainly some of that is. And I'll talk first about some of the research we do. And I want to highlight with that we really focus on developing applied and usable science. And what I mean by usable science is really just as simple as it sounds, that it's actually some form of applied research that is developed in a manner in conjunction, hopefully in co-production with stakeholders, that is going to be readily used in whatever their management process is. Another category of work that we do can be put in this category I call research integration. And this really has to do with taking, in some form, existing research and helping that research make its way to some sort of end user, to make that research more usable by a stakeholder. And a big part of that is developing stakeholder relationships. For myself, being based in Utah, I've focused my work on developing these stakeholder relationships in Utah, but I also work regionally, and we have others in our organization that focus on stakeholder relationships in Wyoming and Colorado. And then also a function in this research integration category is synthesis. And this has to do with adapting existing research or simply synthesizing that research into some sort of final product that is specifically usable for a stakeholder. Another role of Western Water Assessment is climate information provision. We have some various climate information tools that are available on our website, and these have been developed over the years through interactions with stakeholders. And the final function of what Western Water Assessment does is convening. We often work to convene different groups of stakeholders together, often around issues, say within a state, around an issue of drought or natural hazards. And this can take different forms. Sometimes this is giving webinars, sometimes this is conducting workshops on different topics. So before I start talking about some of the research that Western Water Assessment has recently done, I want to talk a little bit about the process that we go through in doing the work that we do. And this really starts with developing relationships with stakeholders to really understand what their research needs are. And not just what their research needs are, but to over time develop deep enough relationships that there's mutual trust between Western Water Assessment and stakeholders, and also so that we have an understanding as scientists of their management processes, the context of their management. Actually spending time really trying to understand those processes can be helpful in designing research questions and making sure the end product of research is going to be usable for the purpose that it's intended. And before any research that we take on, any larger research project anyway, is started, we really assess the needs of that stakeholder before starting the research. And any larger project that we take on is going to either be coming directly from a stakeholder need or has stakeholders that are going to be directly involved in that research in some way, are going to provide input to it, and are going to use that research when it's done. And whenever possible, we really try to work to co-produce any scientific research. And co-production is really taking things one step further than just simply getting input from a stakeholder. There's often many times that I've observed in different scientific processes and research where much of the research is done and stakeholders are engaged towards the end of that project. And I've seen at times where when that process happens that late, sometimes the manner in which the research has been undertaken is not as usable to the stakeholder as the researcher intended. So we really, not only do we work with stakeholders before starting the research, but we include stakeholders to the best of their ability, because different stakeholders have different level of scientific literacy, different abilities to be able to participate in that research. But the more participation that stakeholders can have in the co-production of that research, the more likely that research is going to be directly usable for their processes. We also often act as scientific connectors. So many times in talking with stakeholders, there may be a way that myself or others on our team can directly help that stakeholder, but we may be able to help the stakeholder simply by connecting them to other information, other research, climate information resources, or connecting with another researcher or organization who has already done similar work, and they can leverage work that's already been done to get the answers they need. And many times my organization and RISA organizations and other similar organizations are referred to as a boundary organization. And what I mean by that is that we operate kind of in the space between academic research and practitioners. And we operate kind of freely in both communities. We're housed in academic research institutions, but we work very frequently with stakeholders so that we can provide kind of that conduit to help aid in getting research from academic settings to practitioners. So in talking about Western Water Assessment research, I want to focus on two particular projects. One that was finished about a year ago, the Weber Basin Climate Vulnerability Study Assessment, and then future work that we're going to be doing focusing on justice, equity, diversity, and inclusion issues. So I began work with Weber Basin Water Conservancy District very shortly after I started working for Western Water Assessment in probably early 2016. Just for background, Weber Basin Water Conservancy District is a wholesale water provider that provides water to about 600,000 residents along the northern Wasatch Front between about North Salt Lake and just north of Ogden. And after several collaborations over the course of probably 6 years or so, Weber Basin approached Western Water Assessment wanting more information about climate change. I had previously worked on them in partnership with many other organizations to develop a drought contingency plan. And we provided some climate information and projections of future Weber River flow for that drought contingency plan. And that process, I think, got them thinking that they really needed more information about that. And they didn't really know how to approach getting more information. So they reached out to Western Water Assessment. And myself, along with collaborators at the University of Utah, Court Strong and Paul Brooks in the Department of Geography, Utah State University, we developed a proposal to develop a climate vulnerability assessment for the Weber River Basin. And we took a scenario planning approach for this project. In the assessment, we provided background on historical hydroclimate conditions within the basin. We provided future climate projections, and what Weber Basin was probably most interested in is future projections of Weber River flow. And we actually used 3 different techniques to provide projections for Weber Basin. And then finally, that information was used in a systems model to assess vulnerability to both different climate conditions, but also factors like changes in population, changes in water demand, land conversion from agricultural lands to residential lands, to see under what conditions that Weber River Basin might face shortages in the future. So the study area for this project was the Weber River Basin. The map on the right there is the entirety of the Weber River Basin, which its headwaters start in the western Uinta Mountains, but also include the Wasatch Mountains north of Salt Lake City and the Park City area. For this study, we looked at it from the perspective of not just the entire basin, but breaking it apart into sub-basins. And on several maps that you see moving forward, you'll see the basin broken up into several of these sub-drainages. This allowed a little more detailed analysis of hydroclimate in each basin so that Weber Basin could see where there might be differences in water availability currently and in the future. So just to give a little information about the historical climate, these next series of figures show different climate parameters with observed historical data from, in most cases, 1905 to, I think this goes to 2019 for this project. And temperatures varied, and each of these lines, it's not really important for this purpose what each of those lines are, just know that they represent the climate parameters for each of these 5 different sub-basins. And in this case, the green line for all of these is the very upper part of the Weber River Basin in the Uinta Mountains. And you can see temperature varies without much of a trend until about 1975. But since 1975, there's been about a 4-degree Fahrenheit increase in temperature throughout the basin. Precipitation since 1905 has varied throughout the basin, as you would expect from other climate records throughout Utah and the Intermountain West. There's no trend in precipitation over the last 115 years. There's just variability. Annual precipitation in the various sub-basins varied from 10 to 60 inches. Looking at April 1st snow water equivalent, You see much of the variability. This data set is much shorter, just from 1979, not from 1905. This data set, you see the same variability you do in precipitation. However, at some of the low elevation sites, particularly those on Ben Lomond Peak at 6,000 feet and 7,600 feet, there is a little bit of a decreasing trend at these lower elevation sites. And there's dramatic variability between sites and from year to year in snow water equivalent across the basin, ranging from 5 to 70 inches. Annual streamflow volume similarly varies year to year with no particular trend in streamflow, but streamflow varies by about a factor of 4 from year to year. So I want to discuss kind of the part of the talk that's most directly relevant to the atmospheric science department is the climate projections that were provided by Court Strong and his student Alex Weech. They took care of the climate projection portion of this project. And he used both statistical and dynamical downscaling techniques to provide future climate projections. The loco-statistically downscaled data set was used. This is the localized constructed analogs data set. One of the reasons this was chosen is because there's the availability of 2 different emission scenarios, the moderate emission scenario, RCP 4.5, and the high emission scenario, RCP 8.5. Also, and kind of more usefully for this project, Court used a data set that he developed on previous projects to dynamically downscale a data set for the entirety of northern Utah. And as I mentioned, this was developed in previous projects several years before this particular study. And Court used the WRF model, the Weather Research and Forecasting model, with the Great Salt Lake model, and then coupled that with temperature and humidity changes from the CCSM global climate model to simulate climate changes under one emission scenario, the RCP 6 scenario, which with the current emissions trajectory, this actually seems like a pretty good choice at this point. And this dynamically downscaled data was really important because it was used to examine spatial differences in temperature, precipitation, and snow that provides much more information than the LOCA data set does due to its higher spatial resolution and coupling with that WRF model. Just to give you a few slides talking about these projections, the LOCA projections so the statistically downscaled data set for temperature changes across the entire Weber Basin. By mid-century, these temperature increases range from 3 to 6 degrees, depending on emission scenario. And by the end of the century, a modest 5 degrees under the low end of the RCP 4.5 scenario to as much as a 14-degree temperature increase. Looking at precipitation projections using the LOCA data set, just looking at the raw data, it's hard to see much of a trend, but across both the moderate and high emission scenario, by the end of the century, there's a projected approximate 5% increase in annual precipitation. There's really not much of a difference in that absolute change between the emission scenarios, but there is greater interannual variability with the high emission scenario. So this slide here presents temperature projections placed on a map of the Weber River Basin from the dynamically downscaled data set. And these are projections for 2090, the end of century. And just to give you a little reference point for these figures and the upcoming maps, this kind of outlined blob on the left of these is the Great Salt Lake. And this larger outlined blob here is the Weber River Basin and all of the different sub-basins within the larger basin. And looking at this data set, it allows us to look at some spatial variability within these data. You can see here for temperature projections for March that there's significantly higher temperature increases projected for the lower elevations of the Weber Basin compared to the higher elevations of the Weber Basin. And this is likely due to the fact that in March by 2090, there's no longer going to be much of a snowpack at low and even to mid elevations within the Weber Basin. However, in March at the highest elevations, where we see about a 2-degree temperature increase, smaller temperature increase, this is likely due to the persistence of snowpack at the highest elevations. If we look on kind of a temporal scale, in February compared to the other months, there's a lower magnitude of temperature increase, especially compared to April and May. And if you look in April and May, the greatest temperature increases are found at the highest elevations of the basin. And this is largely due to the fact that comparing this to the historical data, snow is typically present in April and May. And by the end of the century, while there will be a good snowpack during winter at the highest elevations still, there's likely not going to be snow on the ground during these months by 2090. This map and figure here shows projections of snow from the Court's dynamically downscaled data set. On the left is 2040, on the right is 2090. These snow projections are projections of snow water equivalent. And in 2040, there's a slight increase in snow water equivalent projected at the highest elevations, or not even just the highest, but the higher elevations of the Weber Basin, but a 6 to 20% decrease in SWE at lower elevations. However, by the time we get out to 2090, there is decrease in SWE of up to 55% at almost all locations in the basin, except for a slight increase in SWE at the very highest elevations in the headwaters of the Weber River in the Uinta Mountains. Now, the final figure I wanted to look at going into with projections from this study is looking at projections of snow water equivalent again for 2090, but looking at this on a monthly basis and thinking about some of the changes that we're seeing compared to historical period. During December through February, there's increased SWE projected at higher elevations in all 3 of these months, especially during December and February. However, in the shoulder seasons of winter, November and March, we're seeing a decrease in snow water equivalent at all elevations, except for the very highest elevations in November. And if you also couple this with data I did not show of projected precipitation changes from this data set, that shows a large increase in January and February precipitation. So taking that information in mind, along with the snow projections, this is suggesting that there's an intensification of winter, that we're going to see more intense precipitation during December through February, and overall a shortening of the winter season due to less snow, especially in November and March. And finally, I just want to highlight that this project really tells a story of a real success story of effective long-term collaboration with a stakeholder. And this is exactly the kind of relationships that Western Water Assessment tries to forge and maintain. There's been a 10+ year history of engagement with the Weber River Basin. And the fact that we developed this particular project was really the culmination of relationship building, understanding stakeholder needs, and building mutual trust over many years. In terms of actual work with the organization, this started with presentation of existing relevant climate research in the early 2010s and established Western Water Assessment as a trusted source for climate information. And then beginning in 2016 and 17, Western Water Assessment partnered in developing a drought contingency plan that began to look at climate change impacts on stream flows. And then that led to Weber Basin seeking to obtain a greater understanding of climate change and ultimately to this climate vulnerability assessment, which is Really kind of a forward, I really want to commend Weber Basin for being very forward thinking in really putting this much time and resources into understanding how climate change is going to affect their system. While they're not the only water provider that's looking into climate change in this way, Salt Lake Public Utilities has been looking into climate change for even longer than Weber Basin has. I think it's really a success story and really good forward thinking work on adaptation for Weber Basin. Now, briefly, I just want to touch upon research that we're going to be starting to do that is related to justice, equity, diversity, and inclusion issues, or JEDI issues. We really, moving forward on this particular version of Western Water Assessment, we're really going to be seeking to think about these justice, equity, and diversity issues across all of our projects and all of our research, and where we can use it as a guiding framework for the kinds of projects that we take on, the kinds of stakeholders that we interact with, and just how we spend our time and what projects we take on. As I've mentioned, there's a strong social science component to the work that we do, not my own personal work, but my colleagues at Western Water Assessment. And part of that is developing evaluation metrics for how our organization and our partners are influencing building resilience to changes in climate in communities and other organizations we work with, and how well we're achieving some of these goals related to justice, equity, and diversity issues. This is a relatively new topic for us working on. So this is a case where we need to focus on some of those skills and time that we spend on developing new stakeholder relationships to start to address these research concerns. And just very briefly, I want to mention a few projects that we'll be working on over the next 3 or 4 years that have a strong JEDI component to them. One of these is working with Wyoming frontline communities. And again, what I mean by frontline communities are communities that in some way, for various reasons, are underserved and that we haven't worked with much in the past. And we haven't worked a lot in Wyoming over the last several years. So we're going to be undergoing on a pretty large outreach effort to work with frontline communities in Wyoming and understand what their needs are to build climate resiliency in their communities. And issues, especially in Wyoming, that are important are adaptation for carbon dependent communities. There has been a trend towards decreases in coal extraction, and these things are probably going to continue in the state of Wyoming and will be issues communities need to deal with. Another project that I'm going to be working on myself is looking at the sense of place, this idea of sense of place and how that relates to adaptive capacity in communities in the Intermountain West. And for this project, we're focusing on communities around large reservoirs that have been severely impacted by drought. So the places we're going to be working in are communities around Lake Powell, Blue Mesa Reservoir in Colorado, and Flaming Gorge in Wyoming, and how communities, people, businesses, and organizations that live and work around these areas have had changes in how they conceive of the reservoir and that place as it's been hit by severe drought. And in the case of Lake Powell is somewhere around 160 feet below its full pool reservoir. So there have been very dramatic changes to some of these landscapes. And then to take this information from kind of a more social science perspective and use that to help understand how to build adaptive capacity and build resilience to these changes and future changes. And the one project I want to highlight here is the project on the right, building climate resilience in rural gateway communities. This is a project that I'm going to be partnering with Danya Amore here at the University of Utah. She's the director of the Environmental Dispute Resolution Program. And she has an ongoing project called the Gateway and Natural Amenity Region Initiative. And this project seeks to work with what she calls gateway and natural amenity communities. So these are usually small rural communities near national parks or other natural amenities that tourists and other people are drawn to, and working with these communities to deal with the issues that are associated with increases in tourism. And while climate resilience is only one of those issues that these communities face, that's I'll be working with Danya with these communities to understand what these communities need to build climate resilience. So the second component of what Western Water Assessment does that I'd like to talk about is research integration. And the one component, building stakeholder relationships, and a particular project, the Colorado River Basin State of the Science report that I'll discuss. So what I mean by research integration is taking research and science and taking that a little bit further than many times goes in standard production of scientific research and publication of that research in journals. Taking that research a little bit further and doing the things that are needed to make it more usable to practitioners that might need that information. And this really requires deep and lasting relationships with stakeholders. And that's where I spend a lot of my time, is developing and maintaining relationships with stakeholders. And some of these stakeholders may include resource managers. We've certainly worked with a lot of water managers in the past, but also includes forest and range managers, local governments, planners at different scales, be it community planners, hazard planners, state and federal agencies, and non-governmental organizations. So developing stakeholder relationships is really a primary activity of Western Water Assessment, and it's paramount to developing usable science. I really seek to listen very carefully to stakeholders to understand what their needs are and understand the context of their management so that I can help design research, provide climate information that really suits their needs. And some of this involves maintaining existing relationships, but especially with this, with our new 5-year grant, this will require reaching out to new stakeholder groups. As I mentioned in some of the previous slides on some of our research associated with justice, equity, diversity, and inclusion, and also working on the topic of natural hazards requires us to forge new relationships and networks with stakeholders. And this is developing stakeholder relationships is a really time-consuming process, and it's a process that is not necessarily it doesn't necessarily pay immediate dividends for the time that's spent during that. And I think that in my experience working with many scientific researchers, and many of those that even have a very strong desire to develop applied research, to work with stakeholders, it takes a lot of time to work with stakeholders and to really develop those relationships. And this is kind of where Western Water Assessment has a unique role, and the way that we're funded through the RESA program allows us to spend the time that we need on developing and maintaining stakeholder relationships, when many times the time spent on these relationships is not always very easily cataloged. 5 hours of time working with a stakeholder doesn't always necessarily lead to a tangible product right then, but it's potentially laying groundwork for things that may or may not happen in the future. In 2020, almost 2 years ago now, Western Water Assessment finished work on a synthesis project, the Colorado River Basin Climate and Hydrology State of the Science report. In Western Water Assessment, 2 of my colleagues led a team of scientists to synthesize all research related to climate and hydrology in the Colorado Basin. This was really a very heavy lift by my colleagues. The amount of research and synthesis of research that went into this project was enormous. The U.S. Bureau of Reclamation was the primary stakeholder in this project, but there were collaborators and funders from across the Colorado River Basin, from all the basin states, many federal agencies, and many large water providers. This report contains information about historical climate and hydrology, primary planning tools used by federal agencies and water managers, weather, climate, and hydrology observations, information about hydrologic models, information about forecasting, weather, climate, and stream flow forecasting. A synthesis of research that exists on paleohydrology of the Colorado River Basin to give a longer and broader historical context to hydrology in the basin, and information about climate change informed hydrology. For anyone who's interested, this report is available on our website. Another activity that Western Water Assessment that's important to some of the work that we do is information provision. While it's not our primary task, Western Water Assessment is a climate information provider. One of our kind of flagship climate information tools is the Intermountain West Climate Dashboard and associated climate summaries. And we also have an extreme events database. The Intermountain West Climate Dashboard is a climate information resource that's available on our website, updated daily in most cases, that provides information specifically for Colorado, Utah, and Wyoming, but it also provides some information from across the West about temperature, precipitation, and snowpack, drought, current stream flow and stream flow forecasts, reservoir storage, and seasonal forecasts. We also have kind of a parallel dashboard called the High Plains Dashboard, which provides roughly the same information, but it focuses on the High Plains region. So Montana, Wyoming, Colorado, Kansas, Nebraska, and the Dakotas. Along with the climate, Intermountain West Climate Dashboard, I write monthly climate summaries that are published I try to get it published within the first week of every month. And this provides a monthly summary of weather and climate for Colorado, Utah, and Wyoming. I also provide a brief discussion of a significant weather event or climate event that's happened that month. Once a year, I also write a summary for the water year after the water year is concluded. And I'm going to use air quotes, a forecast for the upcoming water year. I think we all know we can't really forecast that very well, but often at the beginning of the water year, there are things we can say about likely trajectories of where the water year might be going. Kind of in the same category of things, we also have, we publish rapid responses that are to climate and weather events, detailed analyses of some of these events. We did this in 2013 for the floods on the Front Range of Colorado, and I wrote a summary like this for the Marshall Fire that happened just at the end of 2021 in Boulder County. While this is an activity that we haven't been focused on recently, with the work we're going to be doing on natural hazards over the next several years, this is something that is going to become a priority. And as we do see climate and weather extremes in our region, we'll be working to write up analyses of these events. And the final thing I want to mention briefly in this category of work Western Water Assessment does is we have a extreme weather event database on our website. This provides information about high impact and extreme weather events from 1862 to present. It's an online searchable database that includes information about cold waves, dam failures, debris flows, drought, flood, hail, high wind, landslide, tornadoes, wildfire, and winter storms. This focuses on events that happen in Utah, Colorado, and Wyoming. And we're working on a redesign of this interface right now. We recently launched a new website, and with that, we're kind of revamping some of the tools that we have. The final function of Western Water Assessment I want to discuss is the convening function. And what I mean by that is we often either work on projects or conduct workshops or provide webinars that convene different groups together. Usually this is around a particular topic like drought or natural hazards. And sometimes the goal of this is just simply to get groups together to start talking about the issue. Sometimes there might be a more directed goal, such as developing a collaborative group to address a particular topic. And specifically, I want to talk about two projects, one that worked on building climate resilience in small communities, and then a project that's just about done developing a Utah hazard planning tool and the workshops that went along with that. Beginning in 2018 and carrying into 2019, Western Water Assessment conducted 6 workshops in small to medium-sized communities in Utah and Colorado with the goal of building climate resiliency to natural hazards in these communities. We worked with 2 communities in Utah, Moab, and then the Zion National Park region, the 3 small towns of Springdale, Rockville, and Hurricane. And in Colorado, we worked with Durango, Cortez, Carbondale, and Routt County. And because these occurred in 2018 through 2019, many of where we were experiencing severe drought in our region, many of these were focused on drought. The core of what these projects were 2 half-day workshops. And the workshops began by providing relevant location-specific climate information about specific natural hazards that these communities cared about. But most of the workshop actually was really driven by the participants. We facilitated brainstorming amongst the group of participants, usually 8 to 15, about climate risks, how a changing climate affects natural hazards, how it impacts their community, and what potential adaptation strategies might exist. And after the workshops, Western Water Assessment wrote a report providing a summary of the climate information and all of the information that was discussed in brainstorming about climate risk, impacts to communities, and adaptation strategies. So these projects, they needed to start with what we call the community champion. So again, these projects started through stakeholder connections of talking with different communities, and where we found communities that were really interested in how climate change was impacting natural hazards. Usually a single person emerged as that community champion. And this person really acted as our liaison with the community and helped to assemble the right participants so that we had a group that really included all of the appropriate people for whatever topics we were discussing. We conducted pre-workshop interviews with all of the participants to understand climate concerns they had, what natural hazards concerned them most, and to just understand a kind of a lay of the land of that community of management, infrastructure, any political considerations that might be important. And these meetings really started with a climate presentation that was specific to the community. And climate communication was really important in this part of the project, both understanding through previous conversations what issues are most important to the community, but then also communicating that climate science appropriately. And we found that these workshops were most helpful in communities beginning to address vulnerabilities to climate change, and could then, this report and the facilitated brainstorming sessions could serve as kind of a launching off point for further, more detailed projects addressing climate change and natural hazards, or just general climate adaptation. And the final project I want to talk about is a project I've worked on to develop a Utah hazard planning tool. So this project really kind of combines several of the modes that Western Water Assessment works in: information provision, convening, and research integration. And the goal of this project was to develop an information tool for hazard planners in Utah, and for this tool to provide historical incidents of natural hazards in Utah, current risks, and where possible, projections about hazards in the future. And at the core of this project was really engagement with stakeholders. The idea of the project came from previous work with the Utah Division of Emergency Management on their 2019 revision of the Utah Hazard Mitigation Plan, where Western Water Assessment provided climate change information for the project, but it was really a very brief amount of information. And the division realized after publishing that update to the hazard mitigation plan that they really wanted more information about climate change. So as a part of this project, I convened 2 workshops with hazard planners from Utah. There were, at the 2 workshops, there were between 20 to 35 participants at each workshop because of COVID. These workshops were held in an online format. The first was in March 2021, and the second was in this past January. The goal of the first workshop was to obtain feedback on a draft version of the Utah Hazard Planning tool and to get feedback on that. This is kind of that iterative process of developing. In this case, this isn't new research or new usable science, but making this tool as useful as possible to this particular user group. At the meeting, we also presented about hazards in Utah, climate change impacts to those hazards, and existing climate change and hazard planning that's happening in Utah. The second workshop presented a final version of the tool, but most of the meeting focused on group discussions about what else is needed to incorporate climate change into hazard planning in Utah. And this served as a bit of a give and take, not just getting information from this group so Western Water Assessment can better provide information to the group, but it also served as a platform for people who work in the hazard planning community in Utah to speak with one another. Many of these individuals and organizations know each other, but not all of them speak with each other routinely. A final component of this project was to provide additional climate change information. There are not good tools for projecting all future climate hazards. There are for some, like extreme heat and in some cases extreme precipitation, but many hazards such as drought, wildfire, debris flows, landslides, avalanches, there aren't any tools that project future hazards. So I sought to create a document to synthesize research and general scientific understanding about how climate change is impacting natural hazards in Utah, and essentially conducted a literature survey and synthesis of research related to climate change and Utah hazards. As much as possible, this was regionally or state-specific information. And this was a synthesis that was written specifically for hazard planners, not other scientists. So it's as much as I can, it was distilled and written in such a way that it's going to be useful for this group. And this entire project is leading to future work with the Utah Division of Emergency Management on how to incorporate climate change into hazard planning. Climate change is a big focus for the division, but they are still working at ways to effectively incorporate climate change into hazard planning. And as I'm running a little short on time, I'm kind of just going to skip through Western Water Assessment Program goals for the upcoming 5 years. I have this slide here just to highlight that partnerships with organizations are really key to the work that Western Water Assessment does. It wouldn't happen without collaborations with other researchers, other research organizations, and close collaborations with stakeholders. And I'm sure this alphabet soup here represents, 5 or 10% of the stakeholders we actually work with. And with that, I'd be happy to answer any questions there may be in the remaining few minutes.
Okay, thank you, Seth. This was a very interesting talk. And with this, I'm opening up for questions. Okay, I have a question. Going out into the rural communities of Utah and talking to those stakeholders, I imagine this may be somewhat difficult to sensitize them to questions of climate change, and there may be a lot of skepticism on science in general, climate change in particular. So how do you deal with it? Or is that true, or is it not true, my suspicion here? And if so, then what do you do?
Your suspicion is right. I think that there's I think at times skepticism about climate change in rural communities. However, I don't typically encounter a lot of problems with how I communicate that climate science. In my opinion, there's a lot that can be done to communicate the issue of climate change. And I do that by not even talking about climate change for a while. Like when I'm giving a presentation about climate or natural hazards to really just about anyone, actually, I first start, I talk about weather and the climate that we've seen and the climate that's been observed. And while climate change has become a political issue, and what we should do about climate change is a political issue, weather is not usually a political issue. And there's usually not much dispute about actual observations of weather and climate over time. So I always start any climate presentation by talking about past weather and just showing what the trends are in past weather. And often in rural communities, in most rural communities in the West, certainly in Utah, there's usually an agricultural component or an outdoor recreation component, and all of people involved in those kinds of activities, they're great observers of the weather. Farmers are very good observers of the weather. And for the most part, a lot of the people I talk to in more rural communities, they've seen these changes and they aren't disagreeing with it. And so, I mean, before I even get into talking about climate change and projections about climate, I really focus on what's happened in the past. And then I also like to bring it into focus. It's one thing looking at like average temperatures or precipitation across the county or the whole state, but I also try and bring in weather and climate events that people have they might have personal attachment to or stories about. So if I'm talking about flash flooding in southern Utah, I'll briefly talk about some cases of flash floods that have happened in the last 10 years, and people are usually going to identify with those events happening. So before I even talk about climate change, I try and tap into people's kind of natural connection to weather, and in many cases climate, if they're involved in certain activities and have seen changes over time. And I also don't focus on attribution. You know, myself as an individual and a scientist, I know that we're seeing anthropogenic climate change, that really the solution for this is to reduce carbon emissions. However, the work that Western Water Assessment does, it's not about adaptation, or it's not about mitigation. It's about building resilience, adaptation, providing information to foster a greater understanding of what has happened and what will happen. So I find the most contentious things about climate change are, what are we going to do about it? Are you going to make me stop driving my truck? Are you know, am I going to have to drive an electric car? You know, my cousin works for the oil and gas industry. Is he going to lose a job? Like, I kind of sidestep those particular issues because those aren't important. I mean, they are important, but they're not important to the specific goal that I have of trying to create a greater understanding of past and future changes, and really to promote resilience and adaptation. We just don't work in that mitigation space.
Okay, good. Thank you. Do we have more questions? Okay, it's exactly 4 o'clock now, so I think that's a good time to end the seminar. I want to thank you one more time, Seth, for your willingness to talk today, and hereby I want to close the seminar. Okay, thank you.
All right, thanks for the invitation to speak, Thomas. Have a good day, everyone.
Bye-bye.
Bye.